Welcome to the Stormsurf video surf forecast for the week starting Sunday, January 18th. Looking at significant wave height charts for the North Pacific Ocean, we see one area of prime interest, a storm developing off Japan, generating 42-foot seas. Also, lesser seas pushing into the Pacific Northwest, the result of a previous dateline gale that is now all but gone. First up, we take a look at jet stream level charts. Now notice we're using a different chart than normal because the GFS model has been upgraded by NOAA, and the data feed that we use to get that data and build our own charts is down and currently not operational. We believe NOAA is working on it, and in the next several days that system should be back up and running. But for the time being, we use the University of Hawaii's upper level charts, which are actually quite good. Notice 190 knot winds pushing off Japan, falling into a nice trough just west of the dateline and feeding storm development down at the surface. Solid winds continue over the dateline, just about hitting Hawaii, and then the jet stream basically starts to split a little bit right here, but still is reasonably cohesive, flowing into the U.S. West Coast. Let's put this into motion. Roll this out. Notice the trough continues to build while pushing east over the dateline on Monday, and then into Tuesday, continuing very solid. The wind's down a little bit, down to about 160, 170 knots, but still just continuing on. Notice this trough here, just holding into Wednesday, and if anything, starts to build and deepen into Thursday again. Notice 190 knot wind starting to build into the jet, feeding low pressure up towards the western Gulf of Alaska. We put this into motion. That trough continues to build into Friday. 190 knot winds, very solid, falling into the trough. Hawaii right here on the hairy edge, perhaps getting a little dose of weather in association with this upper level flow. Anyway, we roll this out into Saturday. The trough starts pinching off. Notice a big split in the jet here. Most of the energy pushing up into British Columbia, but a good, healthy amount of energy pushing towards Mexico as well. This will likely set up high pressure at the surface off California, but it's this trough that is the prime area of interest, supporting gale development pretty much through the week, and then even by the weekend, that trough still holds somewhat, but winds are moderating a little bit. Splits jet stream hangs over the U.S. West Coast. No sign of rain. Next, we take a look down at the surface. Surface level winds, surface level pressure. Now, these charts aren't quite as well refined as we think ours are. It's harder to discern exact wind speeds, but roughly you could say 55 knot winds are in flight in association with the storm currently off Japan and blowing well to the west, if not a hair bit, or well to the east, if not a little bit to the southeast, primarily targeting Hawaii. We put this into motion. Notice this system holds together very well with 50-plus knot winds continuing into Monday morning, and then even beyond that into Monday night. And then the fetch starts fading out a little bit. And notice it also starts taking, if you knew the Great Circle paths, they kind of do this sort of an arc into the U.S. West Coast, and they start pushing a little bit more up the Great Circle paths towards the U.S. West Coast. Anyway, we roll this out some more. A secondary fetch develops 50 knot winds on Tuesday, and that continues east, but then fades out, and then we're in pretty much the 40 knot range into Wednesday. But notice this, yet another decent-sized fetch of 40-plus knot northwest winds are taking aim on Hawaii at this point in time. This is being Wednesday night into Thursday. Also notice another storm starts developing, 50 knot winds off the southern Kuril Islands on Thursday night, and that starts building and pushing to the east. 55 knot winds in this one as well, approaching the dateline on Friday night into, here we are, Saturday night. It finally starts fading out, but still 45 knot winds on the dateline. So two significant systems appear to be in play based on the models. Next, we take a look at the result of those winds blowing on the ocean surface, and that is seas, production of seas. In this case, 42-foot seas over a small area off Japan in association with the 55 knot winds that currently are blowing there. A storm for sure. As we watch this area grow, notice seas grow to 40, 41, 42, 44 feet as of late Sunday night, pushing 47 feet into Monday morning, and then 48 feet mid-Monday morning. This is a good, solid area, good fetch area. Definitely high seas. Relative to Hawaii, very westerly angle, about 303 degrees coming into Oahu, and about the same for Maui. Relative to Maui, that is almost shadowed. The top half of this fetch would not be, but right here in the core, that's pretty much shadowed by Molokai. Anyway, but into Oahu, all that energy is coming right down the door to that area. Anyway, we'll put this into motion. We'll leave the Great Surf. Oh, actually, also let's take one little examination here. Relative to Northern California, notice the angle here, the swell vectors are a little bit east-southeast of the main track. Still, that's 30 degrees is about what you get a 30-degree spread on these seas, and that pretty much still puts good energy up about the 286, 287 degree path into Northern California, and about the about 290 or 291 degree path into Southern California. Roll this out. Notice we get another good blast here, another 6 hours later. Again, on the same basic tracks, 305 to Hawaii this time, and what is that? 284 to Northern California, 287 or 288 into Southern California. And then the system starts falling apart as it crosses the dateline. Still, you get up to 44-foot seas on Tuesday morning. Relative to Hawaii, notice this now. Most of the energy starts passing almost, not quite perpendicular, but let's say 60 degrees perpendicular to the 319 degree path into Hawaii. Sideband energy for sure, especially down here. These seas are bound for Hawaii, but the more concentrated energy here is probably going to bypass and be focused more on Northern California for sure. What is that, 286 or so, and Southern California 289 or 290. Anyway, and you roll it out, and then things quickly fall apart. But notice some fetch holds in this area, and that new fetch, we saw it on the wave height chart, starts building back here on the wind chart. Sorry. Another area, 26-foot seas, again aimed at Hawaii on the 313 degree path, and for that matter, a certain amount into California as well. Roll this out some more. We're into Thursday morning. Still solid sea production there, and then it sort of fades out. Hawaii to be front and center for all this. The bigger issue might be it could almost be, because it's so close, it could almost be out of control large. We'll have to see how this plays out. But the new storm starts forming Friday about midday. 40-foot seas. That rolls up into a good little area here of 44-foot seas. And relative to Hawaii, that's about the 310 degree path. Northern California, what is that? 295 degrees, which isn't bad. And Southern California, a little bit more to the north, like 302 degrees or so. And we roll that out, and it makes it about to the date line on 06Z on Sunday. And again, looking pretty good for Northern California, about 292 relative to Hawaii. 319 degrees. Certainly something bearing worth watching. And then we put this out, and it still holds together reasonably well, but starts fading out. Still quite a ways out. Unknown whether the second system will develop at all. But the first system appears to be well on track. It's been on the models for a week now, and not a whole lot has changed. If anything, the 12Z run this morning actually bumped that system up with a peak C reading of 53 feet, but now it's back down to 48 feet. So solid swell certainly looks like it's on top for Hawaii, with longer period, more inconsistent energy for the U.S. West Coast, but swell to result nonetheless. Next up, let's look at long-term predictions, see what's going on, long-term factors. Right now, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When these numbers go negative and stay negative, they suggest at least the active phase of the MJO, and the active phase of the Madden-Julian Oscillation is responsible for helping support storm development in the North Pacific in the winter months. Currently, right now, we have a dip in the daily Southern Oscillation Index, down, well down, to minus 29.72. Pressure both in Darwin and over Tahiti are down and driving the numbers down. The 30-day running average minus 6.28 and the 90-day running average minus 7.12. The 30-day average has been down in the 0.8 range since the middle of October. This certainly suggests some sort of weak El Nino in play, and at a very minimum, a long-running stretch of the active phase of the MJO. All good for storm development in the North Pacific, and we're seeing some of that evidence in the storm track right now. Next up, we check out surface wind anomalies. These are wind direction and speed differences from normal for this area for this time of year. Currently, weak easterly anomalies in the very far western Pacific, sort of suggestive of the end of the active phase of the MJO, but not necessarily. Notice westerly anomalies on the equator, right in the on the dateline region, and the area we're really interested in is just a couple degrees either side of the equator, running from about 140 east to about 170, this area. When you have westerly anomalies in here, what that means is trades have died, or if anything, are pushing to the west. That helps create a Kelvin wave, which is a warmer than normal pocket of water that travels under the ocean surface on the equator the whole way to the Galapagos, gurgles up or erupts along the Galapagos and starts warming equatorial waters, including down into Peru in that area, and that is the hallmark of El Nino. Anyway, we don't have westerly anomalies in the far west Pacific at the moment. We did, though, a week ago, very strong ones for a good amount of time. They are moving to the east now, suggestive that the MJO is in the active phase of the MJO is moving to the west or to the east as well. We continue here, and here's better evidence of it here. Looking over the central and eastern Pacific, strong west anomalies here under Hawaii. The issue in terms of Kelvin wave development is the cutoff for Kelvin wave development is roughly somewhere right in this area, and most of these winds now are starting to push out of the Kelvin wave generation area. They still have a positive influence. If it was the tropical season, you would actually see these winds helping to support tropical storm formation, but we're pretty much past that time right now. We go a week out and notice westerly anomalies are still forecast, and if anything, growing back here to 160 east, suggestive that this westerly wind burst and this active phase of the MJO maybe isn't over yet, and that it still has some legs to it and still some support for Kelvin wave development. This is in the West Pacific, and notice the easterly anomalies that were forecast in this area are to dissipate. The westerly anomalies actually start taking over almost to about 150 east. This is a good sign. And then as you go into the eastern Pacific, again, westerly anomalies continue almost south to Mexico. This would suggest that the MJO is continuing to work its way east, which it does. It moves west-east along the equator, and as it moves further to the east, it starts dragging weather into the U.S. West Coast. We'll see whether that really happens. There's no evidence of it on the charts yet. Here's another way to look at westerly and easterly anomalies. This chart here is basically the whole planet on one chart. We're interested in the West Pacific that starts, let's say roughly about here and goes to the East Pacific, which is roughly about here. And the reds and these colors are westerly anomalies. So we see them in the Indian Ocean in December, and you can literally draw a line that goes basically like this over time. Notice time going down here. So you see the progression of the MJO from the Indian Ocean into the West Pacific in January, and now here in the west, almost the central Pacific dateline region, and then here's the forecast for the next week, holding in that area, if not anything, retrograding a little bit. So this is all good here in terms of Kelvin wave development. Next we examine the outgoing long wave radiation projection. That is, the blues are areas of cloudiness. That means more sun absorption. The oranges, yellows, and reds are clear sky, more reflection. This is indicative of the inactive phase of the MJO, this of the active phase of the MJO, and we're only interested on the equator. Draw the line right here. So this suggests the active phase of the MJO is roughly on the date line currently, and this is the statistic model, and that over the next 15 days it progresses east and sort of peters out, and the inactive phase of the MJO is building, getting ready to make its entry into the West Pacific about 15 days out, so that would be, about the first week of February. But the dynamic model suggests that the active phase of the MJO is actually supposed to hold its position through about 10 days out and then redevelop, sort of backtrack and then re-get itself together over the West Pacific. This would be the ideal situation. No guarantee that it's going to happen, but an interesting projection just the same. And finally, the upper level model, which doesn't support any of that. The greens suggest areas that are favorable for precipitation, and that typically is where the active phase of the MJO is, and the yellows and oranges are areas that are not favorable for precipitation, or the inactive phase. And this model runs about a week ahead of reality. So it's suggesting the active phase of the MJO is in the Central Pacific as of right now, and the inactive phase is working its way into the West Pacific. The active phase is basically supposed to be out of here, pushing into the northern half of South America by the 28th of January, and the inactive phase takes over. It continues into about the middle of February, and at that time, some sort of a very weak active phase starts developing and drifting into the Pacific. So that would be our next pulse, starting, let's say, mid to late February and going into sometime maybe in early March or so. So we'll see. Certainly the MJO does influence these storm cycles. We are in the active phase right now. We have seen storm development and a very strong storm occurring right now, and another one scheduled over the next week. Next, we take a look at ocean surface temperature anomalies. Changes in temperature, differences in temperature from normal. El Nino, if it were to be happening, would be right in this area, and you should see reds. We do not see it, but we do see warmer than normal water, half a degree or so, nothing spectacular. Still, any kind of warming in this area tends to feed the jet stream, tends to promote storm development. The past several winters, we've seen nothing but dark blues here, so this is indicative that some sort of warming is going on. This is what we'd call a Modoki El Nino, sort of El Nino, but not really. But the little bit of troubling is there's cool water here off of Peru and the Galapagos Islands. The thought is this is the upwelling phase of the Kelvin wave cycle. And we'll get into that in a minute. The thought basically is this is a temporary situation and that warming will redevelop in this area. But still, there hasn't been a lot of warming regardless during any of this El Nino. We do not think that an El Nino is happening this winter, and it's not going to happen. If it would have happened, it would have developed by the end of December. It hasn't done that. If anything, it's starting to look weaker, but it doesn't look like it's going to fade out completely. No one really knows for sure what's going to happen, but this is sort of a classic Modoki El Nino setup where it kind of teases you but never quite gets there. But there's lots of warm water in this area. This is the area that we're mainly interested in, and at this time, it isn't really going anywhere. Here's another look at sea surface temperatures. Here's actual temperatures, actual wind speeds. These are the deviations or anomalies from normal. Notice water temperatures here off of the Galapagos Islands are almost neutral, exactly what the previous chart showed. But notice there is good warming, 1 degree air in this area around the date line in the far west Pacific, and actual wind anomalies. Here's our westerly wind anomalies. This recorded by actual buoys. It's not modeled. This is the real deal. Sensors are actually reporting that winds anomaly-wise are from the west. That doesn't mean they're actually blowing. Here's what they're actually blowing. Basically, they're just the trades have slacked off in this area. But that is enough to set up a Kelvin wave development. Let's go take a look at subsurface level temperature. Here's actual water temperatures. Notice the X's down the stream. These are actually buoy lines, sensors on the buoy lines going depth. So we're looking at a cross section of the equator across the entire Pacific Ocean from the West Pacific to the East Pacific. It's not the actual temperatures we care about. It's the deviations from normal. And notice water temperatures have have cooled off dramatically. We had a big pocket of 4-degree anomalies here a couple of weeks ago. That was a Kelvin wave. It worked its way to the east, gurgled up on the surface, and pretty much hasn't done a whole lot. If anything, we're getting negative anomalies starting to show here. But notice there is some warming starting to build in this area. Not a lot. The thought is the westerly winds that we have created a little pocket of warmer water. The question is, are there going to be more westerly anomalies? Is it going to be enough to generate a Kelvin wave, send it across the Pacific, and start warming water temperatures again? If we were to go into a multi-year El Nino, even a multi-year Modoki El Nino, one would expect to start seeing another Kelvin wave develop and work its way off to the east. Here's NOAA's chart of upper ocean heat anomalies. You can see Kelvin waves very easily on this chart. West Pacific this side, East Pacific this side. Massive Kelvin wave made its way across the equatorial Pacific, February, March, April of 2014. Upwelling phase of the Kelvin wave, cooler waters. Then another mini Kelvin wave in August. A stronger Kelvin wave in October through December. And then here's the new Kelvin wave that we're watching. It actually doesn't look quite as organized as it did maybe 2 or 3 weeks ago. We're still looking to see whether any of this water is going to start making its way off to the east. The hope is that it will, but there's no guarantees. But at this time, we suspect it probably will. And finally, the forecast from the CFS version 2 model for the Nino 3.4 area. This is the area that is normally associated with monitoring El Nino. Current water temperatures suggested about half a degree above normal. And the forecast is basically those temperatures hang in there through even July. So the spring unpredictability barrier, roughly March through maybe the first part of June. Never know what's going to happen here. The models say one thing and nature does whatever it wants to. But the thought is basically water temperatures on the equator are supposed to hold in this general temperature range about like they are now. And then we start getting into warming in July and almost 2-degree anomalies by October. And one would assume even more, because this is definitely El Nino territory. By the time you get to December, maybe you're up to 2.5 degrees. So this model suggests that a developing El Nino is expected, if one can believe a model that goes 6, 9 months, 12 months out. Most of the other models that do this sort of projecting are forecasting some sort of steady state, just this lukewarm kind of thing, which would suggest maybe year 2 of a Modoki El Nino, which still wouldn't be bad. It'd be better to have the Modoki El Nino than the big El Nino scenario, because once you get a big El Nino, right behind that is a big La Nina and a total shutdown of the storm production machine in the North Pacific and more drought. So if we had a multi-year Modoki El Nino eventually culminating in a full-fledged El Nino, that would be a good thing. We get some surf out of it, maybe get some rain out of it for the Southwest U.S., and a better picture in general. Anyway, we'll see. It's very much unknown at this time. But back to the short term, the number one story is the strong storm forecast off Japan. It is developing. One would expect that it'll probably do about like what the models say. Large swell expected for Hawaii, and groomed long period swell, but a little bit less consistent for the U.S. West Coast if all goes as expected. Beyond that, another series of lesser gale for the Dateline region, meaning more swell for Hawaii and the U.S. West Coast, and then maybe even another storm pushing off the Kuril Islands a week out, again making for longer period swell for all targets. Looks like a pretty good scenario, so we're happy. Winter is here. The active phase of the MJO is delivering as expected. This is good news. For now, go get some surf. We'll do this again next week. Same time, same channel. See you there. Thanks.